Hello. Well, now that I've got a mill, I've been working on making a new rudder servo for Woodstock using a worm wheel. In order to do that, I've got to have the gearing running in oil, which means I need an oil-proof gearbox, as it were. And this is causing me a bit of a problem to work out how to do this satisfactorily. So that's what this video is about, up to a point. Well, the idea is that I make something that might fit in this box, and I've just been experimenting with making holes for bearings and seals. This seal required a 14.8mm hole, so I had to use a boring head, which is something I've never used on the mill before, so that was interesting. So we might have the rudder down here and a worm wheel like that, driven by a motor, possibly with more gearing. But this gearing has got to be in an oil-proof box, because it's a feature of worm wheels that they scrape the lubrication off themselves. So I want it half submerged in oil, and then when the boat is rolling around it'll get splashed all the time. So, ignoring the exact details of this, what I want is to make a box by fixing pieces of aluminium together like that, having previously milled them with the necessary holes for the bearings, etc. So this has caused me to think about possibly brazing these pieces on, because that at least would be oil tight. Whereas if I just bolted them together, I mean, the alternative is to bolt them together and put some non-setting joint compound like Hylamar in between. But I thought, I wonder if I can braze them. I've just got two test pieces of aluminium, and I've just milled them flat on one side. That's flat, and this is flat. So if I put this on here, there should be no gap between the two pieces, and I'm going to see, if I try brazing them like that, whether capillary attraction will carry the braze between them or not. Because I've just been reading watching a YouTube video on brazing, and it said that you should have about a 3 thou gap between the parts if you want capillary attraction to carry them through. But the example that they showed of this kind didn't seem to have anything maintaining that gap. So I'm going to try this first, and then try machining the middle part of this down by 3 thou, so that we definitely do get that gap, and see what the difference is. Right, well, I'm just going to weight this down in a symmetric way, hopefully. That's all right. This is Alu-flo 440, which I think is now called Alu-flo ZA. Anyway, it's an aluminium zinc alloy brazing rod with a built-in flux, which melts at 440 degrees C, which is quite low, almost soldering. So we'll see what happens. happened to that? Well, I plunged it into cold water and washed the flux off, which I was supposed to be able to do, but the result is not satisfactory. There's a hole here. It looks as if the penetration is only 50% across there. But the worst thing about it is, and I'm not sure if you can see this, but I can see it on a magnifying glass, there's actually a crack all the way along here. And whether that was caused by plunging into cold water or not, I don't know. And I guess I can break this. I'll try breaking this in a vise now. Right, well, this is going to break easily, I feel sure. Yes. Well, what we see there is that there was no penetration into the... Actually, it went like that. No penetration into the underneath at all. Although this is wet, so water could get in there. So what that establishes is that we do actually need some clearance in order for the braze to penetrate between the two parts. So what I'm going to do now is clean it off and then mill 3 thou clearance across here, from here to there, and do it again and see if it gets a good braze across here. I mean, how you're supposed to maintain a 3 thou clearance otherwise, I don't know. That's interesting. I was just milling off the braze from the preceding effort, and you can see that it's actually penetrated into the workpiece. I don't know if you can see that there. Which means presumably the workpiece was close to melting, which is odd. Well, I've milled that flat again and cleaned this up, and then I've milled a 3 thou slot across here. Put it round both sides this time, which is cheating, of course, compared with the last time. And we're going to let it cool down naturally rather than plunging it into cold water. Right, well, it's cooled down now. So it was round like that, and I applied the braiding stick all the way around. This inner side, the side that was this side, is quite neat. That end is quite neat. But this side, which was the side I suppose I was mainly heating it on, has actually cut into the aluminium again. which is slightly odd, because I didn't think it were anywhere near the melting temperature of aluminium. But anyway, there are no cracks in it this time. So I think what I'll do is cut it down here with a hacksaw and see what the cross section looks like. Well, actually I think it probably will be right in the end, so we'll save a bit of elbow grease. Well, that's much more successful. There's no visible join, it's just continuous aluminium. You can see along here where it splashed up the side and ate into the side of the thing. I don't know why it does that, but anyway, that's a very good join, no cracks or anything. Should we try and wrench it off? My problem is that I want such a join all the way around, and of course it doesn't do so at the end here, because I had a stand-up bit to give the necessary clearance. Right, well, I put the thin bit in the vise, and I'm just going to see if I can just move it, break this off this way. Yes! No trouble at all. Well, that's how it was, and it looked absolutely fine until I broke it off sideways, when it is clear that the braze has not penetrated into the centre at all, despite, as you should be able to see here, that there's a 3 thou standoff. In other words, that little edge there is 3 thou higher than the rest of this, and still it is not penetrated at all, which is completely useless. That's no good. Back to the drawing board. One lesson of this is it's not good enough to hacksaw or bandsaw the workpiece in two to check it out, because the action of the saw actually covers up any imperfections. What I should have done is polish that to a fine, smooth surface before assessing its condition. The braze is supposed to follow the hottest part, and I'm just wondering if I'm getting the outside of this aluminium hot, but the centre isn't hot. But on the other hand, aluminium is a very good thermal conductor, so it should all be at roughly the same temperature. I don't get that. It was completely clean before we started. We just machined it, and I degreased it with isopropyl alcohol. This is not good. I did one more where I heated it up without any obstructions, and then when it was sufficiently hot and I'd satisfied myself that this rod was melting on here as well as on here, I then just held it down and brazed it all the way around. So we'll see what that's like. Oh, that's better. It's holding much better. Not sure I can actually break that now. No, that's definitely going to hold. I think that's well and truly on. I went to an auction in Reading of a machine shop that was closing down because the proprietors were retiring, and I bought 4 boxes of stuff. These 2 are mainly reamers, and these 2 are end mills. Some of them, these ones here are too big for my mill, but the rest of them are quite useful if you want roughing end mills. There, and there are some here, all different sizes, down to very small ones, all of which I could use. And then I also collected this, this was actually, funny enough, this was the cheapest thing, this cost me 20 quid, which is a 6-inch vise, but it weighs about 25 kilograms, and it's like a bit like putting an elephant on a cigarette packet, I think, to put this on my mill. But maybe I'll clean it up and sell it. I need something that's a bit lighter than this, and a bit bigger than the one that I've actually got. A bit bigger than that one, which is only 3 inches wide. So I'm going to have a big sort out of those, keep the ones that I really want, the metric ones and so on, and put the rest of them on eBay. Well, I'm thinking that I could practice more with this low temperature aluminium brazing, but that it's not going to be at all convenient to braze all the edges of, all the inside edges of an aluminium box, and I'll probably revert to the idea of bolting the box together or screwing the box together with set screws, and either using a non-setting sealant like Aluminium, or maybe even using araldite between the parts just before I assemble them to make it oil tight. Thanks for watching.